Okay, hi everyone. So today we are going to continue with what we started in the object-oriented concepts, and today we are going to talk about interfaces, and we are going to talk about abstract classes. Then we are going to say what is the difference between both, and when to use each of those two. So, first we are going to define some of our concepts, and then we are going to dig deep into each of these concepts and understand them together. So, an interface is a reference type in Java. And it's a little bit similar to classes, but we are going to say what is the main differences. So an abstract method is a method that is declared without any implementation, and we are going to say what is this means, and we are going to see together how to provide it with the implementation. So an interface is also a collection of abstract methods. So what is abstract method? Abstract method is a method without implementation, right? So in interface, now we know that you cannot have a method with implementation inside. So a class implements an interface, and the class that implements that interface is going to provide an implementation to all these abstract methods. And we have something called abstract class. And this abstract class is a class that is declared abstract. So it's declared abstract, but it also may or may not include abstract methods. However, if you have a class that includes abstract method, then you should make this abstract. You should declare it as abstract. Abstract classes cannot be instantiated. So this is one of the main general rules in Java. Abstract class cannot be instantiated, but they can be subclassed. Also worth noticing that an interface also cannot be instantiated. So you cannot create an object of an interface because an object is of a class. However, if this class is abstract, then you cannot create an object of that abstract class. So along with abstract methods, an interface may also contain constants, default methods, static methods, and nested types. So let's start talking about interface first. So an interface is thus a type definition anywhere an object can be exchanged, for example, in a function or a method call. The type of the object is to be exchanged can be defined in terms of one of its implemented interfaces or base classes rather than specifying the specific class. That means what this means is that any class that implements that interface can be used. So usually a method defined in an interface contains no code, no implementation, right? So it cannot itself be called. So you need a class to implement this interface, so it provides an implementation to this method. Then you can create an object of this class. The class implemented this interface. We are going to see all this together. So why do we actually use interfaces? For many reasons. One of the main important reason is that in Java, you know that you don't have multiple inheritance, right? Multiple inheritance means that a class extends more than one class or multiple classes. However, you can do that with interfaces. With interfaces, a class can implement multiple interfaces. So, because we want to create abstract classes, abstract methods in both abstract class interfaces, let's first get to know the abstract methods, because we need them in both interfaces and abstract classes. After that, we are going first to focus on interfaces, how to do them, how to deal with them, how to exactly do implement of interface. Then we move on to the abstract classes. So let's get to the abstract methods. As they are declared without any implementation, as we said, they must be declared within abstract class or interface. So you can never see an abstract method in anywhere beside abstract classes or interface. So they are declared with the purpose of having the child class provide the implementation, because if you have interface with abstract method, you need a class to implement that interface so it implements the method. If you have abstract method in an abstract class, then you need a class. We are going to call this class as a concrete class, because a class that is instantiable or that can be instantiated is called a concrete class. A concrete class. So you need a concrete class to provide implementation to the abstract method, and then you use that class. So they're declared with the purpose of having the child class providing the implementation. And we are still talking about the abstract methods. An abstract method is a method that is declared without an implementation. Thus, there is no braces, no curly brackets, and it followed with a semicolon. Like you would have abstract, int, max, and this. However, if you're using interface and you're creating abstract method in an interface, you don't need the word abstract. You don't need it. You just, because every method in an interface must be abstract, so you don't need the abstract, because this abstract keyword is used when you have abstract class that may have a method without implementation. Then you would say, okay, this method without implementation is an abstract method using the abstract keyword. So let's now talk about interfaces. So basically, talk about interfaces. One of the good examples would be the soda machine. The soda machine works exactly this way. You drop some coins, and the machine counts the coins. If you have enough coins to buy a drink, then you get to select the drink. After you're selecting the drink, then the machine is going to hand it to you or drop it in a hole where you can get it. Now, to our extent, we don't know what's going on inside of this machine, right? We don't know what's going on inside of this machine. You just dropped some coins. The machine did everything. If you dropped enough coins, then the machine drops your drink in here, right? So this is one of the famous concepts of encapsulation. Why? Because we hide the implementation of the soda machine, and what you're dealing with is only the interface. Right? Only the interface of the soda machine. But you don't know what's going on in the back end of the soda machine, right? So you honestly have no idea how it really works. All you know is that you put some cash, you press a button to select a drink, and if you put enough, you get your drink, right? If you don't put enough, you get a message on this screen that says you don't have enough money, right? So, to add to that, you know how to use the soda machine's interface. So, therefore, as long as the machine interface follows the usual soda machine interface, you get to use it. This is what we call the interface contract. The interface contract. Why? Because if you fulfill your end of the bargain, which is putting the money, selecting a drink, the machine fulfills its end of the bargain, which is doing the calculation, doing the math, and picking up your drink and put it in the hole. So the machine can be bringing the drinks from Antarctica or the conveyor belt or anywhere on the earth. You don't know. And you honestly don't know what is inside picking your drink and put it in the hole. Whether it's a monkey, a rabbit, a robot hand, you don't know. You honestly don't know. As you can see in this photo, it's covered, right? So you don't know. What you know is that it's a contract. You do your end of the bargain, the machine does its end, and you both are satisfied. So, if all soda machines implement the same interface, so I could program a robot to use the soda machine, and it could be able to use it. I can ask my friend to use the soda machine, and he or she would be able to use it because they are all dealing with the same interface. And the interface is easy enough for anyone to use. So because we have a standard interface, my friend or the robot could use the buy soda algorithm to buy a soda machine. The buy soda algorithm would be put in some money, press a button. If you have enough money, you get your drink. If you don't have enough money, you get a message. So there is a mechanism to help provide the standardization. So polymorphism is the idea that when you use the soda machine interface, it could be doing different things, right? It could be doing different things internally, but from the outside, you just use a standard interface. For example, I would have a class called soda machine, and this I'm going to name it Coca-Cola machine. This is going to implement the interface soda machine. So it should provide implementation to all the functions, abstract functions, in the interface. One function could be count the coins. The other could be show a message. Count the coins is going to show a message whether you have enough money or not. And the other should be of type void and start working on getting the drink. Then another machine should be bringing the drink and returns the drink, right? So all these things can be standardized using one interface. Another class would be Pepsi machine. And this is going to be for Pepsi machines. And so on. So this is why encapsulation and polymorphism are closely related. Polymorphism gives you the idea of that you can use one interface for more than one machine, right? For more than one class that use the machine. and you can call them all soda machines, because the Coca-Cola machine is implementing the interface of soda machine, so it's a soda machine. To me, from the outside, it's a soda machine. Pepsi machine is doing exactly what the soda machine's interface is saying, so it's a soda machine to me, because I can apply the same concept on both Pepsi and Coca-Cola machines. And the encapsulation is that using the same interface, I don't know what is behind that interface, what class is implementing that, as long as I can follow the same steps to get my drink. So in polymorphism, all you know is that you're using the soda machine implementation, which can be changed. And as a result, different things can be done behind the scenes. This leads to the driving concept of polymorphism, which is the ability of one object, the soda machine, is actually acting as both a monkey soda machine or a converged soda machine, depending on the machine actually behind the interface, behind the scenes. So today, we are going to create an interface together, and we are going to create kind of a difficult kind of interface. If you can do this, you should be able to do simpler interfaces. So this is another way we can create a standard that allows us to use different objects interchangeably. So the interface lists the methods, and those methods have to be implemented in a class that implements that interface. So this is going to allow us to count on these methods being there. Okay, so create a project and add this interface. So the interface is going to be public interface comparable item. So in this interface, we are going to have a function called compare to. Compare to takes an item, and this is called generics, and we are going to see what generics is in a few seconds. So it's taking any type, as long as this is non-primitive type. Non-primitive type means that a type that can be instantiated. Or we can make objects of. So that takes any type and returns int. Okay, so before we get to this example, I'm going to show you how to do that in Eclipse. So we have this interface demo object. You can create sandbox for this object, and we are going to create interface with comparable. The way you do create interface, you do right click and new create interface. This is how I created this .java file. So public interface comparable item. And you can do that or not. It's going to be working perfectly without any problems. You can just do public interface comparable item, and we are going to do public in comparable item. Since you have seen this extends the comparable item that is basically defined in Java.lang library. And I'm going to show you why I had this last time I created this interface in a few minutes. So going back to another example that would explain the interfaces very well, then we go back to the comparable example. This is exactly if we have the outlet example. The outlet example is, as long as I properly implement any device to use the correct type of voltage, I can use the outlet to power it, right? So you need to do two basic things, right? One, you must have the correct plug, And you must be able to properly handle the 110 AC in your device in here, right? If you have those two things in your class, then you can implement or use this interface. You can use this interface. Now, interfaces in software engineering allow us to plug into methods that require certain behavior of work. Also, they allow us to create consistent public interfaces for a group of objects without inheritance. Without inheritance, they don't have the is-a relationship. So that said, reasons for an interface. Another use of an interface is being able to use an object without knowing its type of class. I'm going to show you in this example what that means. That means, for instance, if you were annoyed by a whistling noise, you hear someone or something, or you just hear a whistling voice, whistling sound. Now, you don't know exactly who's whistling. Now, we know that a parrot can whistle, a human can whistle, right? So it could be either, but you don't know. What you know is the behavior. The behavior is someone is whistling. Who is whistling? You don't know. This is the idea of using interfaces. Like both humans and parrots, they both can whistle. So they both implement the interface of whistling. But they are not actually children of the whistler class, right? Because it doesn't make any sense. They have to be they have to have is-a relationship, and if they're both extending one class, then they have to be related in somehow. Now, an interface defines the signature operations of an entity, like the whistling, right? Like the whistling. It also sets the communication boundary between two entities in case of two pieces of software. It generally refers to an abstraction that an asset provides of itself to the outside. Like the parrot is whistling itself to outside. How to express itself? By whistling. But also the abstraction is that a human can also whistle and can express himself or herself to the outside by whistling, but they're actually not related to each other. So the main idea of interface is to separate methods from implementation, right? Any request that matches the signature or the interface of an object may also be sent to the object, regardless of its implementation. And this is actually polymorphism, right? Polymorphism. So, since it does not matter which implementation of a specific class is used, a class can be exchanged easily without changing the code of the calling class. The concept of an interface is fundamental in most object-oriented programming languages. So, in some, objects are known only through their interfaces. So, there is no way for you to access an object without going through an interface. Like whistling, again. You know that we have a whistler. And I know this entity, whether it's a person or a parrot, you know that this is a whistler. So you know them only through their behavior. Behavior means interface, right? Their interface, the whistling. So uses of an interface, if you want to specify how classes exchange messages. For example, like every time when a class should be reused or used outside a specific context, a specific package, declare the communication interface as interface type. You would use it as interface type because they're not related and they're in different packages. you have to switch the implementation of the of a module during a runtime, or at a design time, you don't know which implementation yet you will use at a compile time. Here is the three usage of the interface. So when a class implements an interface, it allows an object created from a class to be used in any context that expects the values of the interface. This is one type of type safety, right? Type safety. When we say type, data type safety. So an interface is a contract. Interface is a contract. So you can look at this as a contract. For example, if you have in a number of situations in a software engineering environment, when it's important for disparate groups of programmers to agree to a contract. Like you can see that in Amazon and Microsoft, you have more than one team, and every team is working on a specific thing, but they all serve one purpose: creating the software for you. So those teams need some kind of a contract. Some kind of a contract that spells out how their software interacts. Because they're building the same software, they're building one software that is formed from more than one entity, right? So each group should be able to write their own code without the knowledge or any knowledge of how the other group's code is written. So generally speaking, interface is a contract. Interface is a contract. So going back to this one, the Java interface is a collection of abstract methods. Now, when we say a collection, does not mean that we should have more than one abstract method. Now, we have interfaces with only one abstract method, and we actually call them functional interfaces. Functional interfaces, we are going to talk about them when we get to anonymous classes, lambda expressions, all these things. And we have another kind of interfaces. They're including more than one abstract interface. Now, a class implements an interface, thereby inheriting every abstract method in this interface. That means this class must provide implementation to all the abstract methods. Now you're asking, what happens if this class does not provide implementation to all the abstract methods? Keep that question in mind. That question is going to be answered when we get to the abstract classes. So, along with abstract methods, an interface may also contain constants, default methods, static methods, and nested types. And we have said that in the primary summary in the first slide of the summary. So, and an interface contains behaviors that a class implements. Since we are talking about a class implementation, if you're implementing an interface, interfaces are used to encode similarities which the classes of various types share, but do not necessarily constitute to a class relationship. For instance, a human and a parrot, they both can whistle, but they're not actually related. They don't have a strong relationship to be a subclasses of a class. So rather, they most likely would be subclasses of an animal class, but both would implement the Whistler interface. So in a more practical example, sorting algorithm may expect an object of type comparable. Why? Because when you sort, you need to compare two entities, two objects, right? Because how would you sort numbers if you don't compare them to each other, right? So if you're talking about objects, not just numbers, objects, then you should have them as comparable. Have them as comparable means if you have comparable interface that would provide a compare to method, then your objects, if their blueprint, the class they're belonging to, if it implements comparable, those objects could be compared to each other. So without knowing the specific type, it knows that objects of that type can somehow be sorted. And this is what we are creating. And remember we said comparable, the one we are doing in this example, has the compare to, which is used to describe two objects as equal, or one of them is greater than the other. Now, what we said before is that comparable is a generic interface. Generic means that it allows implementing classes to specify which class instance can be compared to them. And if you have anything of type generic, it could be used with any data type. This is actually going to be one of our stops in the future lectures. We are going to have one full lecture about generics, but today I'm going to present to you just how to use generics and to briefly explain to you what is generics. So first, we're going to create a friend class, and we are going to add this code. And here's the friend class. In this friend class, you have first name, last name, age, phone number, and email. And age is the only different type. It's of type int. You have a constructor that would set them all, and you have the toString method that would print the first name and the phone number. The first name and the phone number. Okay. Up to this point, here's what we have. And then let me continue. This is what we have. And let me just do those steps with you. I'm going to set this as if we are doing the exercise together. So here's what you have right now. Then we're going to create a demo class with a main method, and we are going to add to the main this code. So, okay, going back to Eclipse, here is the demo. Here is a class demo, and here is the main method. We are adding this code, and we are going to have this sort. Let me just put it in here, because so what you have right now is you have a sort. Let me just comment that because I'm going to need it in a few seconds because I'm going to ask you to copy it. So now copy this method and put it below main. And in a second, I'm going to explain what this method means. So I copied that method and put it below main. So let me just uncomment this and explain this. So this method is called sort. It returns nothing, but there is one big condition in here sitting, waiting to be explained. And it takes an array as input. Array of what? Array of type item. What is item? So you're taking item, but we don't have anything called item. So we have to define what is item. Item's definition is in here. Item definition is item, any object of a class that extends comparable interface. So again, what is this item? So basically, if you're writing a method, you're going to do this, right? This is public static void sort item and your array, right? Your array name. Then what is item? Because you don't have anything. Like for example, if I would have here friend, I can do that, right? Because I have type friend in here. But I don't want this only to take friend. I want this to take any object in the whole word. So I would just set it to item. But then what is item? Item is a placeholder. Placeholder to what? To anything that is extending comparable. Any object of a class that a class is extending comparable. So where are we going to see this class? We are going, because we want to compare friends. We're going to say implements comparable. And this comparable, what kind of items you're comparing? Friends. Comparing friends. Okay, now we have done this, but we have an error here. The error here is when you hover over with the mouse in here, the error says add implemented method or make this class abstract. Why? Why to make it abstract? Remember, in comparable here, we have an abstract method, right? So if you have a class implementing that method, this class must provide an implementation to this method in comparable. However, if this class does not choose the first option to implement the method in comparable, this class must be defined as abstract. So this abstract class would have a child, and this child is going to implement the compare to function. So we are going with the first option because this is what we want for now. So the first option is doing this. Compare to, and this compare to is returning 0. So basically, let's go back and explain what's going on with the sort method, and then let's see what we have done in when we added the unimplemented method to friend. So first, this method is a generic method that takes anything, any type, and this type must be extending, or in this case, implementing comparable. So this type is implementing comparable, but since we don't say in a method declaration implements, we say item extends comparable, not implements, because we now think of this as a strong relationship that qualifies to be extends. So item is not a type but a placeholder. This is what I've said in minutes ago. So in this case, it must be a type that extends comparable. So to write this method, you want it to be able to sort many different types. Because it's a placeholder, it could be replaced with a student, a friend, a double, a string, as long as this is non-primitive data type. Now, to be able to sort these things, you need to compare two things. And to compare two things, you need to have these two objects, these two things of type comparable, right? Of type comparable. Now, if you have them of type comparable, then this object must have the compared to. The compared to. Why? Because if you're sorting, then you need to use the compared to sort. You need to use the compared to sort. So what we are going to do right now is we have our sort, right? We have our sort method. We called it, and sort was having a problem. What was that problem? Is that you do not implement comparable. So what we have done in here is now, since we implement comparable, if we save this, the demo is going, you just have seen the error disappears. Now we can try this. Now we are comparing based on the age, right? We are comparing based on the age, but we are not. We want this to compare based on the age, but we are not, because if we're comparing based on the age, the first one should be Rick, then Jerry, then Beth, Summer, then Morty. What we see is the final array. It should be the sorted array, right? We see Summer, Jerry, Beth. Summer is 17. Jerry is 46. Then Beth, Rick, and Morty. So it doesn't make any sense. Those are not sorted by age. So what's going on? If we want them to be sorted by age and they're not, because we have a compared to that is pretty much a blank, right? It's a blank. Doesn't do anything. What we need to do is to give it the proper implementation. So let me just put this back to its original state. Here is the proper implementation. That says if we have two people of the same last name, compare them based on their age. Otherwise, just compare the last names. So this is going to first compare the last names. And if we have two people of the same last names, we are going to have them compared by age. So if you're going to the demo in here, we can see that we have 4 people of last name Smith. And we have one of last name Sancti, right? So you know that this Rick must comes first because it's he has the priority in terms of last name. SA precedes SM, right? Then we have those people of last name Smith. They're going to be compared by age. Okay, so let's try it right now. And we have Rick, Jerry, Beth, Summer, Morty. So first we have this. If we change this to 12, we still see Rick at the beginning. Why? Because Rick has the last name priority. Right? The last name priority. Then, those are going to be compared by age. Now, we have Jerry. Jerry is, and this is going to be from the oldest to youngest. So, we have Jerry, 46. Then we should have Beth. Then we should have Summer of 17. And the last is Morty of 14. Right? So go back to our slides. So we added this. I gave you kind of a screenshots to walk you through what I've done in Eclipse. You can do that. You can hover over with the mouse over a friend, and you can add unimplemented method. This is going to add this. That was a blank. Then Sort is now working, but wasn't actually working the way we wanted. Then what we have to do, we need to implement the compare to what we wanted to do. So rules for the compare to. One, that compares the object with the specified object for order. Returns a negative integer if the object is less than the specific object. A 0 if they're equal. A positive integer if it's greater than the specified object. Should agree with the equals method as well. If equals return true, compares to should return 0, because that means we have a match. We have two entities of the same criteria. If you are comparing last names, then two entities of the same last name. Two entities of the same first name if you're comparing last names, and so on. So what we are doing, we say if compare to must return one of three things, right? One, positive. Two, 0. 3, negative. Right? We say if the last name is equal to the last name of the entity we are comparing with, return the age difference. The age difference is going to be either positive, negative, because if we have 46 minus 70, this one is going to return negative. If we have 46 with 45, this is going to be positive, right? And if we have different last names, we would return the difference in last name. Compared to, this compared to is of the string class. And this is going to be comparing letters to each other. So if we have Smith to Sancti, this is going to say this is returning 0. This is returning, the letter M position minus the letter A position in the alphabet. Okay, so we tried this first, and that was the right thing, right? That was the right thing, because Rick, even if we changed Rick's age, Rick is going to be the first one. Because when you look at this list, Rick is of last name Sanchez. I don't know why do I have it Sancti in my code. Anyway. So since we are done with it, now from the Java API, we can use some methods as long as our classes implement the comparable. So one of these methods is going to be collections.sort. Collections.sort if we have our objects in array list or lists. Arrays.sort if we have our objects in arrays. So lists and arrays are objects that implement this interface, the comparable interface, can be sorted automatically by using collections.sort. Objects that implement this interface can be used as also as keys in a sorted map. Keys, not values. And we have one lecture, it's called the hash map lecture. And the hash map, we are explaining hash maps. Then you're getting to know what is key and what is value. You can also use them as elements in a sorted set. Without the need to specify the comparator. This means we do not even need to build our own sort. Okay, what does that mean? It means that we spent our time building our own sort, while we have something ready for us we can use. I'm going to comment this because this is using arrays, right? So now I'm going to show you how to use collection.sort. And actually we are going to use collections.sort a lot this quarter. So here is, I have my friends in here. I have Ricky and Morty, Beth, Jerry, and since I have them in here, this is Jerry. Since I have them in here, I can use collections.sort. Collections.sort in on this list. But wait a second. What is this list? This list is an array list of friends. An array list of friends. And when you go to your demo and you try to do this array list, you have array list of here and you have everything in place. But when you go to for the comparable is an interface and it has its own compare to. But if you try this code, this is going to give you one big problem and says, okay, I have collections.sort, but sort is not working. Sort is not working. Now, why is that? Because the sort is waiting for a list or array list, whatever, of type comparable, but not your comparable. It's a list that is of type comparable from the java.lang. So what you need to do, public interface comparable item extends, this is item, right? Save that, go to demo, and the error is gone. Now try it, and the for loop in here, the for each, is printing the first name and the phone number of each of these friends, right? Because this is what in friend, it's called toString, and toString prints the first name and phone number. Okay, going back to where we're at. So we can call collections.sort or collections.binary search. We can also call arrays.sort, arrays.binary search. We can use objects of classes that implements comparable on tree map or tree set. In tree map, we can use them as keys. In a tree set, we can use them as elements. And don't worry about those things because just keep this information the way it is, because you're going to understand what is a key and what is an element when we get to that in the lecture of hash mapping. Okay, some other common interfaces are serializable. Serializable is a marker interface. Basically, this is an interface without any method or any fields. It's just an empty body in there. So why do we have it? Because if you implement this interface means that it indicates that your class can be serialized. Your class can be serialized. So the Java doc describes how it should function, although nothing is programmatically enforced. So for example, you can see some comments in there and what your class should be able to do or it should be, but it's not actually going to force you to implement a method because it does not have any methods. So serialization is kind of the conversion of a state of the object into a byte stream. Deserialization is the opposite of that. So if you want that to be said differently, serialization is the conversion of a Java object into a static stream of bytes, a sequence of bytes, which can then be saved to a database or transferred over a network, and so on. So we use the interfaces to enforce the idea of encapsulation, and this is also promotes the idea of loose coupling. So coupling refers to the degree of direct knowledge of the one element has of another, or object has of another. Interface promotes the idea of that you can only need to know the methods in the class, not how they actually work internally. So to implement a method, and this is very important. This is important. Why? Because to declare a class that implements an interface, you include the implement clause in the class declaration. So class X implements interface Y, right? Without the word interface. Y is interface, then class X implement Y. So your class can implement more than one interface. If you want to implement more than one interface, then class X implements A, B, C, D. So it's something like this. If I'm going to show you a dummy, if we have interface A, I'm not going to add any methods. I'm just going, interface A. And I'm not going to add any methods. So just do this. This is B. And this is C. And I'm going now to have a class X implements A, B, B, C. So this is how it's being done. So by convention, if you have implements clause and extends clause, then implements goes after the extends. For example, if I have another class in here, let's call that class W. Class W. And this class X extends W. This is how it's being done. Class X extends the class with inheritance, extends W, then implements whether it's one or more than one interface. You can implement 1, 2, or 3. Okay. So implementing relatable interface. Relatable is one of the famous interfaces. This relatable interface shows that your object is comparable to another object in size. So any class can implement relatable if there is some way to compare the relative size of objects. So if you implement relatable, you have to provide implementation to is larger than. And is larger than could be comparing, for example, if we are doing that on strings, we could be comparing the number of characters. If we are doing that on books, we could be comparing the number of pages. If we are comparing students, we are comparing their weight or their grades or their GPAs and so on. For planar geometric objects, area would be a good choice if we are having rectangle plus class that follows in these slides. While volume would work for 3-dimensional geometric objects. So in all previous classes, string, books, and all these things, they have to implement is larger than method, right? And if you know that a class implements relatable, then you know this class somehow is comparable in terms of the size of the object. Now again, the size is up to you. Want to define this size, number of pages, number of characters, and so on. So right now we are done with exercises, with interfaces. What I want you to do is to go to do this exercise. So pause the video now and do this exercise. So this exercise is asking you to consider if you're designing a vehicle engine, and this vehicle engine, you're going to do some software. The software is to create an interface for your engine. It's called engine, and in this engine you have two abstract methods: change gear and speed up. They both take inputs, and this input could be different. So you create a class vehicle implementing the above interface and implements its methods, and you just print this object you have created and give it those two. And here is a sample output of your screen. So now pause the video and go do the exercise. Okay, assuming you came back after you have done this exercise, I'm going to show you the solution. Now, the solution to this one, let me just open, I have it ready in here. This is the interface exercise. Let's see, going to the here, just remove everything in here and let's try it in here. So first, here is your interface. I'm going to have them all in one file. So here's the interface. Here's the interface. It has two abstract methods, change gear and speed up. And we have a vehicle that implements the engine, and it has speed and gear. You have to implement speed up, and you have to add the input you get to the speed. And the gear is having this equal to the gear. Now you can do this for the speed up. You can do speed up because it speeds up, or just taking that and you always provide a bigger input. So here is the toString, because if I ask you to do just this, print the object, then you have to implement the toString. Otherwise, if we do this and we try this thing, then we have just the class name and the hash code of that class. So having this toString implemented, that would print the 3 and the 7 of the gear and speed of the vehicle. Okay, this is what I asked you to do, and the solution to that exercise is going to be published after the due date on Canvas. Okay, so the summary right now of interfaces. So an interface is a list of methods you need to implement. You can think of it as a some kind of contract. It allows you to be able to use a code or to write a code without any knowledge of others' codes and how they're writing their codes. Implementing an interface is similar to inheritance. The only difference is that you can implement more than one interface, but you cannot inherit or extend more than one class. Interfaces are a powerful mechanism to promote a code reuse with much lower coupling than inheritance, because inheritance, it's a strong relationship. So comparable, the one we spent our time talking about, is an interface that is a part of the Java library. This interface imposes a little ordering on the objects of each class that implements it. And we have seen how to use it. We have seen how to use collections.sort. And collections.sort, remember, even if you have your own interface, you need your interface to extend the Java .lang comparable interface. Okay, now let's move on to abstract class. And with abstract classes, we are not going to spend much time because it's going to be pretty much the same concept you have learned before, but this is a class that uses abstract method, or that contains abstract method. So abstract means existing in thought or as an idea, but it's basically not having a physical or concrete existence. So abstract class is one of the powerful constructs of object-oriented programming, and it helps implementing the dynamic polymorphism. It helps implementing the dynamic polymorphism. We're going to see what that is. This will require them to provide certain methods. Developers can then count on the existence of those methods. And you won't understand all this without an example. So I'm providing you with an example in a few minutes. The abstract class is a class that is declared abstract. That is declared abstract. You must have the abstract. It may or may not include abstract methods, but it is declared as abstract. Abstract classes cannot be instantiated. This is in your test. Abstract classes cannot be instantiated, but they can be subclassed. Because they need subclass to implement the abstract methods in them, and the subclass can then be instantiated. Consider the program trying to implement a functionality of displaying a menu. So let me just prove that to you in practice. So when I do right click on this application, it shows me a window, right? Here is a pop-up window with options I can choose from, right? Here is a menu with options that I can choose from. Now, if I go to this Eclipse and right click, I still see. So whenever you go to any application and right click on this application, you must see a pop-up window. But the contents of these windows are not the same. So that means that every programmer extending the abstract class that will show a window, but the implementation of what in this window is different. Now let's make this clear by talking about graphic objects. This is going to show you what do I mean by abstract classes being instantiated or not. So if a class includes abstract method, it must, remember the word must, be declared abstract. So if I have class graphic object and it has int and y, it has a non-abstract method called move_to. It moves the object, whether it's a circle, rectangle, or anything you're going to have, to a new x and y, to a new position. But you have two abstract methods, and if you have abstract method in an abstract class, you have to have the abstract keyword. If you have abstract method in an interface, you don't have to. So we have two abstract methods, draw and resize, and one non-abstract method in the class. Now, why do we have non-abstract method? Because everyone extending this class is going to have the same behavior of move_to. So why having the move_to being implemented in every child? Why not having this, and they by default inheriting the move_to with its implementation? But the way you draw circle is going to be different than the way you draw rectangle. The way you do resizing for the circle is different than the rectangle, and so on. So when an abstract class is subclass, the subclass usually provides implementation for all the abstract methods in its parent class. However, if it does not provide implementation, then the subclass must be declared abstract. I'm going to prove to you that those two points in Eclipse. So abstract classes are similar to interfaces. You cannot instantiate both abstract classes and interfaces, but in abstract classes you can have methods with implementation. So with abstract classes, you can declare fields that are non-static and final. With abstract classes, you can have non-static and final fields and define public, protected, private, concrete methods. However, with interfaces, all fields are automatically public, static, final. And all methods are declared public. All of them. You don't get to choose. In addition, you can extend only one class, while you can implement any number of interfaces. Now, before we talk about which one to use, let me just prove to you what I've just said in terms. Let me just delete this, and I'm going to create dummy interfaces and classes and all these. So interface A. And this interface is going to have a public void method. I'm going to call that compare. Whatever. I'm going to call it compare. And this method cannot have implementation, so it ends with a semicolon, right? So I'm going to add another one, and I'm going to call that do something. Then I'm going to have a class X that implements the interface A. And this class is going to implement only one method. It's going to implement this method. So, as you can see, now implementing a method doesn't mean that we have anything in here. It just means that it has the brackets, right? Brackets with anything inside or nothing inside. Still the same. Now this class must be declared abstract because it's still inheriting an abstract method, this, and not implementing it. So abstract method. Now let's say we have a class Y extends X. Now this class Y is going to add one more method. So public method, I'm going to have that as string. What is that? String. And it's going to be called nothing. And I'm going to return empty string. What that is? Okay, now this works. Now the thing is, you still, Y inherits everything from X. So inherits compare plus the do nothing. But do nothing is abstract, so this is abstract, right? Abstract. Now it works. Now if you want to create an instance, you must have a child of Y. The child of Y is going to be named class. I'm going to name it Z extends Y. And for this class to not give an error or to be instantiated, you have to implement the do nothing or do something. So this class is by default inheriting this and inheriting this. So if I'm going to have a main, wherever I'm going to have main method, and I'm going to create an object of Z, I'm going to call it Z object equal new Z. Now this Z object is going to have the compare, this method, and it's going to have the nothing, and it's going to have the do something. Now, can you actually have a Y object, like Y equal Y? No, you cannot. Because you cannot instantiate the type Y, because it's abstract. However, with polymorphism, you can have Y, Z object, and Z. Because this is the instantiation part, right? You can still have it. But the thing is, you will only see compare, do nothing, and can you actually see do something? You can't see do something because it's from A. It's from A, and Z is providing the implementation to that. Okay, going back to here. So when to use interface versus abstract classes? You can use interface if you expect that unrelated classes would implement your interface. Whistling. Again, back to whistling. Whistling objects, human and parrot. They're not related, and they are both whistling. You want to specify the behavior of a particular data type, but not concerned about who implements its behavior. Also, if you want to take advantage of multiple inheritance of a type, since you don't have multiple inheritance, you can do multiple interfaces. You can use abstract class if you want to share code among several closely related classes. You expect that classes are you're extending, they're actually related, and if you the classes that extend your abstract classes, they have common methods or field or require the same implementation to the same method, and this is proved in here. Here. All the graphic objects can be moved, but they can be drawn or resized differently. Okay, so you want to declare a non-static or non-final method, because as you know, in interfaces, they're all static and final fields. Okay, so here's an abstract classes example. So animal, like you can't say that all animals make sound, but you don't want to specify what sound it is in here because it doesn't make any sense, right? Or if you want to say draw shape, what kind of shape? I can say draw circle, create an object of a circle, but not create an object of a shape to be drawn, right? Because shape is too vague, animal is too vague. But if I say dog, now I know the sound is woof woof, right? And if I say cat, the animal's sound of cat is meow, right? So class demo in here, this is going to create a polymorphic object, dog, and dog makes sound is going to say woof woof. This is cat, and cat is moving. So an abstract class example. In object-oriented drawing application, this is back to drawing and resizing. So in a drawing application, you can draw a circle, rectangle, line, a Bezier curve, or any other graphic object, but you cannot just say draw an object. It's draw graphic object. So these objects have all have certain states. For example, they have position, orientation, they have line color, fill color, and they have behaviors, methods. They can be moved using move to, they can be rotated, they can be resized, drawn. So some of these states and behaviors are the same for all of them, like moving, right? Moving, you can move them from one place to another. You can fill the color of them. You can position them. But others, they require a specific implementation to this object. Like a circle needs a radius to be drawn, right? And so on. So here it is. This is going to be abstract. Each of those extending this abstract with its move to and adding methods. But if you know that all of them share the same behavior, for example, to be drawn, they are all moved the same way, just being given two new x and y. But to be drawn, this rectangle needs height and width. This line needs, for example, just the width. This circle needs a radius, and so on. So the drawing, they share the behavior. So I would have it as an abstract method, but they don't share the implementation of that behavior. So here it is again. Here is the move to, and I'm going now to have a circle here that extends this and implementing the resize and the draw. It has to provide implementation with radius or with anything else. Okay, now the final exercise today is consider you're designing a simple employee detail system. Create an abstract class employee details that shows an employee's common details such as the name and the ID, and confidential details such as the salary and performance. So those are going to be abstract methods, right? And create a class HR that implements the above methods, because the HR can only set what the salary is and what the performance is, right? But for example, another division, another department can see what the name and the ID is, right? Everyone can see what the name and the ID, but only the HR can access the salary and the performance. So your main should look like this, and those two are going to print their behaviors. Like this one is going to print the name and the HR, and this is going to be from the employee details, right? And the HR is going to actually provide implementation to this method, and it's going to print those two. So if I give John a salary of 6,320 and 55 cents, and John's ID is 1, and the performance is good, not bad, then you can also have this as your output. So the solution is going to be published after the due date of this exercise. So let me just give you an overall summary, then show you the answer of this exercise. So the overall summary is the interface is a reference type. An abstract method is a method that is declared without an implementation. An interface is a collection of abstract classes, and the class implements an interface, thereby inheriting all the abstract methods and should provide implementation to all those. And if you have a class that implements an interface and not providing implementation to all the abstract methods, then this class becomes abstract and should be subclassed to implement the other unimplemented methods. An abstract class is a class that is declared abstract. It may or may not include abstract methods. Abstract classes cannot be instantiated. Again, cannot be instantiated, but they can be subclassed. Along with abstract methods, an interface may also contain constants, default methods, static methods, or any nested types. Let me just show you right now. So we are practically done. So let me just show you the answer to the exercise. You just remove all these, paste it in here. Here is the class employee, and since we have one abstract method, it's abstract. If we don't have abstract method, or if we have abstract method and we did not define this as abstract, it's going to give me error. Either you do this as non-abstract and provide implementation like this, or keep it the previous way with the abstract class. Now I asked you explicitly to make this abstract method, so you should know that this should be abstract class. This is going just to provide the ID and the name. Here is the ID and the name printed in common details. And the HR is going just to add the salary and performance, and it's going to provide implementation to the function confidential details from here. This is actually overridden from the employee details class, and it's going to provide them and print them. So if this is your main, this is how it's being done. Let's just run this project, and this should print name John, ID 1, and the salary and the performance. So this is today's lecture. Once you're done with your exercises, don't forget to go to the exercise page on Canvas and upload your .java file that includes your code. See you in next video.